We're going over question 20 on section 1.5, which says, show that it's a one-to-one function and find its inverse. Check your answer algebraically and graphically. Verify that the range of f is the domain of f inverse and vice versa. Okay, so I'm just going to go ahead and find the inverse. So I'm changing my f of x to y. Then I'm trading x and y. And then I'm solving for y. So I'm going to move my 5 over. I'm going to square both sides. Then I want y by itself, so that ends up turning this into y equals, I'll end up adding 1 and then dividing everything by 3. So it's kind of like x minus 5 squared, add the 1 to the other side, divide the whole thing by 3. So I sort of skipped some steps there. Are we okay with the steps that I skipped to get the 1 to the other side and then divide by 3 to get the y by itself? So here is the inverse. It might look a little better if we write it as like 1/3 x minus 5 squared plus 1/3, because then we can see better what that graph, if we wanted to, actually looks like. It's a parabola. The other thing we need to make sure we do on this is to restrict the domain so that x would just be like the positive half of the parabola, because it's a positive square root. So to do that, we would want to see where that parabola starts on the x-axis, or like on the x direction. So we're going to pay attention to this x minus 5 for that. So what is the x value of our vertex? Positive 5. So that means for our domain, we need to restrict it so that x is greater than or equal to 5. So it's just that positive half of our parabola that goes with our square root function. Okay. So there's our inverse. We just want to show that the domain and range are in fact swapped. I don't think there's like formal ways you can do this. Let's graph these really fast. So this one would be moved to the right 1/3 and up 5. I'm going to call that 1/3 and up 5. Because I get to label my own graph whatever I want it to be, which means my graph would look something like this. The 1/3 in front, or this 3 in front, is actually going to horizontally compressing, which is going to be the same as a vertical compression, right? So that just means it's kind of shorter than it would normally be. So that's what our graph itself looks like. You can see it's 1-to-1 across both the horizontal and vertical line test. And then our inverse function would be at positive 5 up 1/3. So I didn't draw this to scale. So 2, 3, 4, 5. My 1/3 is out of whack, not really in the right place. So then it's just half of the parabola going that way. And because I restricted the domain, I've just got the right piece of the parabola. Okay, let's talk domains and ranges. So for our original function, which I guess I drew in green, so maybe it would make more sense to have that maybe green. Our domain starts at 1/3 and goes to infinity. Our range starts at 5 and goes to infinity. Does that make sense? So domain is from 1/3 to infinity, and the range is from 5 to infinity. So now let's look at our parabola. We've got our domain, x value starts at 5, it goes to infinity, and our range starts at 1/3. It goes to infinity. So is it true that our domain and range have just swapped? For our inverse, we've got kind of a graph that shows us that they are one-to-one functions. We restricted the domain to make sure that that was a one-to-one function. I don't know exactly what the book is asking when it says show that, but I feel like everything we have right here is kind of showing that they're both one-to-one. So I think that's sufficient. Does that make sense? Does that kind of answer what you were wondering? Okay. Anything else for chapter 1? For your quiz that you need to take by Friday?